Every machine learning model you will ever build is secretly doing one thing.
Linear algebra. Not the version from your college textbook. A much smaller, sharper toolkit.
Vectors, matrices, one operation called the dot product.
That's it. That's the whole list. This is episode 3 of Machine Learning from Scratch.
No proofs. No pure theory. Every idea ties straight to code you'll actually write.
By the end, matrix multiplication will feel obvious, not scary.
Let's build the toolkit.
Let's start with the vector because your data is already one.
A vector is just an ordered list of numbers.
A house with 3 bedrooms, 1,200 square feet, and 2 bathrooms. That's the vector 3, 1,200, 2.
Every row in your dataset is a vector. Every single one.
Geometrically, a vector is also an arrow, a direction, and a length.
Both pictures are correct. We'll use whichever one makes the idea click.
2 operations matter most: adding vectors and scaling them.
Vector addition. Add each matching position together.
1, 2, plus 3, 4 gives you 4, 6. Position by position. Scalar multiplication. Multiply every number by the same value.
2 times 1, 2, gives you 2, 4. The direction stays. The length changes.
These 2 moves are the building blocks for everything else today. Now, the single most used operation in all of machine learning.
The dot product. Multiply matching positions together, then add up the results.
1, 2, 3 dot 4, 5, 6 is 1 by 4 plus 2 by 5 plus 3 by 6, which is 32.
Why does this matter? Because every prediction a linear model makes is a dot product.
Features dot weights. That's it. That's the whole prediction step. Once this clicks, half of machine learning stops feeling like magic.
If a vector is one row of data, a matrix is your entire dataset.
Rows are examples. Columns are features. One object holds it all. 100 houses, 3 features each, is a 100 by 3 matrix.
That's not an abstraction. That's literally what pandas hands to scikit-learn.
Every dataset you'll ever load becomes a matrix before a model touches it. Matrix multiplication looks intimidating. It's really just repeated dot products.
Each entry in the result is one row, dot product with one column.
Row 1 of the first matrix, dotted with column 1 of the second. That's entry 1, 1. Repeat that for every row-column pair, and you have the full result.
One rule to remember. The inner dimensions must match, or it breaks.
A 3 by 2 matrix can multiply a 2 by 4 matrix. Those inner 2's must agree. You will never do this arithmetic by hand. NumPy does it instantly.
np.array creates a vector or a matrix from a plain Python list.
The @ symbol, or np.a, performs the dot product or matrix multiplication.
One line. Result equals A at B. That's an entire matrix multiplication. Done.
Everything we just did by hand, NumPy does in microseconds on millions of rows. Here's why this episode exists, where you'll actually use this.
Linear regression's prediction step is literally x times weights plus bias.
That's one matrix multiplication for every prediction, all at once. Feature scaling, distance calculations in KNN, PCA, all vector and matrix operations.
You won't write the matrix math by hand again after today.
But now, when scikit-learn does it internally, you'll know exactly what's happening.
Let's lock in the mental model before we move on. A vector is a row of numbers, one example or one direction in space.
A matrix is a table of vectors, your entire dataset, or a set of weights. The dot product multiplies and sums. It's how predictions actually get made.
Matrix multiplication is just many dot products, organized into a grid.
That's genuinely the whole toolkit. You now have it.
Let's use it once, start to finish. 2 features, size and bedrooms. 2 learned weights, 150 and 10,000. A house with size 1,203 bedrooms. Predict its price. Dot product,
1200 by 150 plus 3 times 10,000. That's 180,000 plus 30,000.
210,000. A full prediction from one dot product. That is genuinely what linear regression does under the hood. Nothing hidden. Quick look at where this fits in the bigger picture. Episode 4 covers probability and statistics, the other half of the ML Math Toolkit.
Then we start building real models, regression, trees, forests, boosting.
Every algorithm from here on uses what you learned today directly. This is pure machine learning, start to finish, no detours into deep learning. Episode 4 is probability and statistics, the minimum you actually need. Mean variance, distributions, and Bayes' theorem all tied to real ML use cases.
Right after that, we train our first real model, linear regression, from scratch.
Subscribe so you don't miss it.
Before you go, here's your challenge task for this episode.
2 houses. House A, 1,400 square feet, 3 bedrooms. House B, 1,800 square feet, 4 bedrooms. Weights, $150 per square foot, $10,000 per bedroom. Task 1. Predict House A's price using a NumPy dot product. Task 2. Predict House B's price the exact same way.
Bonus round. Stack both houses into one matrix.
And predict both prices in a single line using matrix multiplication.
Pause the video right now. Open your editor. Try it yourself first.
The full solution, every line explained, is in the GitHub repo. Link is in the description and the pinned comment. Post your answer in the comments. I read every one. Linear algebra isn't a wall between you and machine learning. It's just vectors, matrices, and one operation applied over and over.
You now own that toolkit. Every future episode builds on it.
Episode 4, Probability and Statistics for ML, drops next. Subscribe. Comment if the dot product finally clicked.
I'm Majas. This is CodeToAGI. Let's build.